Hello, and welcome to this module on big data analytics. So, what I would do in the next two modules is try to introduce you to the problems of big data analytics. So, we'll start off by looking at what is big data. Okay, of course, I cannot hope to cover all the aspects of big data analytics in a couple of modules in this course. The whole idea is to give you a very brief, or as I say, a small introduction to big data analytics. So when people started talking about organizing data, and managing data, they initially started with database management systems. You might have heard of relational databases and other forms of data management systems. So the goal here was ease of access, right, and to be able to answer simple aggregation, select queries, essentially trying to do some form of analytics of the data, but by looking at very specific queries that you can run on the data. So the volumes of data were not as large as we talk about nowadays. And then from database management systems, when the data became much larger, that you couldn't make sense out of the raw data itself, and people started talking about data mining or data analytic systems, where the goal was to detect patterns in the data, right? And people used a lot of ideas from machine learning and applied statistics in order to do this kind of data mining to understand the data better. So what has happened nowadays, right? So this whole system has evolved to a point where you cannot just hope to run your machine learning algorithms directly on the raw data, but you have to worry about the data management aspects of it, as well as the analytics aspects of it. So that is essentially the crux of what people call big data nowadays. The fact that the data is so large that you cannot look at analytics devoid of data management. Right? So to give you a feel of what this big data, here is a quote from Eric Schmidt, who was the executive chairman at Google. So from the dawn of civilization until 2003, humankind generated 5 exabytes of data. Now we produce 5 exabytes of data every 2 days. And the pace is accelerating. Right? So if you can just think about it, right? What we have produced for thousands of years since till 2003, we're able to produce that kind of data every 2 days. Right? That's the volume of data that humans are producing, and obviously we cannot make sense out of this data unless some kind of organization and analytics goes hand in hand with it. Right? So what are the main challenges that come about when we are talking about data of this scale? Right? So this is somewhat of becoming a cliched view of big data analytics, but one that is popular. So I thought I should present it as part of this module. So the challenges are essentially encapsulated under the 4 V's of big data. The first, volume, velocity, variety, veracity, and I would like to add a fifth V to it, which is called value, which is essentially the goal of all of data analytics in some sense. So I'll briefly introduce you to each of these V's, and that will be the end of the first module. Right? So why is it that we are able to generate such huge volumes of data? So one of the reasons is that all aspects of modern life has been digitized. All aspects of modern life has been digitized, and nowhere is it more apparent than in your social activity. Right? So you have Facebook. A lot of people spend a significant portion of their waking hours on Facebook, and possibly a significant portion of their sleeping hours dreaming about Facebook. And then they have such volumes of data that is uploaded on YouTube and WhatsApp and Twitter and Flickr and all the web sharing portals, right? So if you think about it, right, almost every aspect of your life is now being recorded somewhere or the other, right? And the next thing is just not the social activities that you perform on online social media, any kind of interactions you're having, right? This with a very high probability is being recorded. For example, phone conversations, right? When you call customer support calls, they are being recorded. Any feedbacks and surveys that you have, that you fill out a form anywhere, that's being preserved for posterity. Any kind of online conversation, chats, WhatsApp transcripts, and other things, they are also recorded. Right? So So it's like everything that you're working at is actually being recorded at some point or the other, right? Another aspect is the increasing availability of cheap storage and cheaper bandwidth that allows us to share multimedia content at rates and volumes that was never imagined possible even 5 years back. Right? So here are a few examples that I took from the internet. So the Instagram is growing at more than 1 billion photographs. Right? And Instagram has more than 1 billion photographs. YouTube has 100 hours of new videos uploaded to the site every minute. Right? And over 1 billion unique users visit YouTube each month. And Facebook adds 30 billion pieces of content every day. And likewise, you could take any of these online portals and you can come up with these mind-boggling numbers that tell you how much data is being shared on these portals. So apart from these the aspects of everyday life and that is generating this data, there has been significant advance in technology in other areas. For example, in biological data, so 3 gigabases of the human genome can now be sequenced in a few days. Right? This is like 3 times 10 power 9 base pairs, which is this is a significant volume of data, but then this is for one human genome, right? And you can essentially get your genome sequenced for a few $1,000 in the US, and soon it should be made accessible at a much lower price range. And so the data is being generated at a very enormous, unbelievable, mind-boggling space. Right? Protein data banks have tens of thousands of structures amounting to several terabytes of data, and again, people are continuing to add to this from experimentation. Right? So to put this in perspective, so Donald Knuth, one of the fathers of computing algorithms and so on and so forth, has this to say about computational biology. I think the most exciting computer research now is partly in robotics and partly in applications to biochemistry. Biology is so digital and incredibly complicated, but incredibly useful. Biology easily has 500 years of exciting problems to work on. It's at that level. Right? And not only is it in the data analytics sphere, which is of most relevant to us, but in a variety of other areas as well, including data storage and also in computing hardware and access technologies. Biology is challenging computer science at levels never seen before. So this is about volume, but what about the rate at which this data is being accumulated? So data is generated at tremendous volumes, but at tremendous rates. Right? Instagram in May 2012, right, 58 photographs were being uploaded, and a new user was being gained each second. And Facebook adds half a petabyte of data every 24 hours. Right? And then let's not even talk about sensor networks, which are generating data almost at a continuous rate. For example, at IIT Madras, we get GPS readings from about 300 buses every 30 seconds. And if you think about the citywide transportation, this is really a small scale. And if we are able to instrument all the buses that run in Chennai city, we can get data at a much, much higher velocity. Right? But just hold on a minute, right? Why are we worried about all this big data? So we are not really, I mean, not every one of us is going to work for Facebook or Instagram or Google, right? So tremendous amounts of data is already available in the public domain, right? Either through Facebook APIs or Twitter APIs or through government data that is being made available on open forums, and we can obtain significant insights from analyzing this public data, right? And you could think about sentiments, you could think about trends, and a variety of things. The kind of insights you can derive is limited by your imagination and access to data, and there is a significant amount of public data available that you don't really have to work for Google or Facebook to think about big data. The second thing is that sensors are becoming ubiquitous, right? So a lot of uh, everyday things that we see are being instrumented and then there are sensors in buildings, there are sensors on bridges and other kinds of infrastructure out there, and people are talking about Internet of Things, which is essentially the whole idea is to connect uh, different kinds of equipment through sensors on low power wireless networks. So once you have these kinds of data being generated by sensors, then you don't have any breadth of volume or velocity of data, and so you would really need to develop techniques like this that allow us to work with data. And as I already mentioned, large volumes of public data is already available. Government is pushing for more access to public information. So due to all of these factors, it really makes sense for us to look at big data, and we don't have to work for such large companies, even though the examples I gave you to make you appreciate the volumes that we have to look at were drawn from these kinds of online social media companies. Right? So the next V I want to talk about a little bit is variety. So traditionally, when we talk about relational databases, we talk about structured data with very well-defined fields, maybe of a few types. You could have strings, you could have numbers, you could have categorical variables and things like that. But now with big data, data coming from different kinds of sources, right? You have many variations on this. So the first and very widely available source of data is unstructured text. So you can get things from the web, you can get scientific articles, newspaper clippings, a variety of sources give you unstructured text. I mean, these are not really marked into saying, okay, this is the heading, this is the most important keyword here, and these are all the attributes of this keyword. I mean, so you don't get this kind of organized data. Essentially, you have to just read free form text, and from that form some kind of a representation which you can then use for your data analytics one. Right. The second source of information nowadays is multimedia. As I've been mentioning, you get pictures, you get videos, and you get a variety of different sources of videos and pictures, and as well as audio, sound clippings, and so on and so forth on the internet now. And so you have to come up with technology for analyzing all of this, especially at a scale. Right. And made mention about sensor data, and again this is going to look like unstructured data, so it's going to be continuous time varying signals that you would be measuring from these sensors. And how would you even record these, how would you make sense out of this data? That's another main challenge. And then you have scientific data, and scientific data comes in a variety of different forms. If you're talking about medical data, it could come in terms of readings from instruments, it could be black and white images, it could be thermal images, or here what I was seeing here is a snapshot from microarray data used in computational biology a lot. And so making sense of this kind of data requires not only new computing techniques but also significant understanding of the domain in which you are operating, and therefore we have to work more closely in collaboration with the scientists who are handling this kind of data, and data analytics cannot be performed in isolation here. So lastly, I would like to talk about linked data. Right? This is essentially data that comes with some kind of structure, but not the kind of structure that we are normally used to. This is data that comes with a network structure. So we're going to talk about entities. Let's look at a small close-up of this. So each of these nodes here, this is a very complex graph, and each of this node here is essentially an entity, and the links tell you how are these entities connected. Right? So such large volumes of linked data which give you relationship between entities is already available in the public domain. And apart from that, many sources of data that you generate nowadays have this kind of link structure associated with it. So now the question is, how would you mine such large volumes of linked data? So this variety, there is tremendous amount of variety, and each of this come with its own challenge, and quite often significant requirement for domain knowledge. So in the next V you look at is veracity. Right? One of the biggest problems in social media data is figuring out if the data that is given to you is true or not. Right? So the falsification of data, I'm pretty sure that many of you have actually given false information to create email IDs and other things online, and there's been cases of people maintaining multiple profiles on Facebook, and so that you selectively share information, etc. So it's hard to disambiguate when you are being false and when you are giving true information. So a significant amount of resources are spent by many of these companies in order to verify the information that is provided to them, right? Or if you take sensor data, right, the data could be noisy, right? There could be some missing values. So how do you account for all of this, right? So how do you trust the data that you're getting from the sensor? Is it, are we sure that the sensor is not malfunctioning? So how do you account for that, right? Maybe if there are a few sensors, right, you can do that manually. But suppose you're talking about millions of sensors deployed over a high-rise building, then the question of manual verification is moot. You just can't do that, right? And I talked about how biological data is one of the biggest sources of future problems for us. But even though there are huge volumes of data available, more often than not, these are estimated interactions and estimated data. And again, you are not sure about the veracity of the data. You're not sure whether, let's say, if you say a protein interacts with another protein, you're not 100% sure the interaction happens. You can say like 80% confidence, I'm sure this interaction happens. So in such cases, how would you handle this kind of unsure data? So these are just examples. If you take any source of data coming from any kind of uh, domain, you'll always find that there are issues of noise and trustworthiness in the data. So the verification, and people still work with this kind of data already, right? And so some of you, if you've already working in some kind of a data analytics company, know that you have to work with this kind of data already, right? But then verification becomes hard due to the scale that we are talking about. So current technology, people typically end up doing some kind of internal consistency checks and some amount of manual verification, but we need something more scalable to work out this big data scales we're talking about, right? And the last V I wanted to mention very briefly is this whole idea of value. So I have all this big data. How do I monetize the big data? Right? So we have to think about problems where, in some sense, the returns are higher than the investment. And now the investment is no longer trivial because we really have to put in a lot of resources in order to just manage this data at this scale and then run analytics on top of it. So all the 4 V's play a role here, and so you basically have to figure out what is the right balance in terms of the effort that you put in and the kind of monetization that you can do. So some examples which people actually try out are on recommendations, trying to build better recommender systems for different domains, looking at sentiment analysis, trying to get a sense of what people feel about new products, maybe movies, or what do people feel about a particular candidate in election. So looking at that, and then other examples include business process optimization, surveillance, healthcare, smart cities. There are many domains in which people are trying to find out monetization for big data. Right? So in the next module, we'll look at some of the challenges in running data analytics at the scale that we have talked about today. Okay. That brings us to the end of this module.